Hi everyone, I'm Juliana, the co-founder and CTO here at Stytch. I'm joined today by Ian Maurer, the CTO of Genomoncology. Ian, so thankful for having you on the show today.
Yeah, wonderful to be here. Thanks for having me.
Awesome. We're going to be talking a little bit about BioMCP, an MCP server that you all have been working on, sort of what went into that, and sort of diving behind the code to understand some of the work that you've been doing to support MCP. So to kick things off, I'd love to hear just a little bit of an intro on yourself, Genomoncology, what you all are working on.
Great. Yeah. So Genomoncology is a 13-year-old small business out of Cleveland, Ohio. We actually help a variety of labs. We actually help 17 as NCI designated cancer centers and some major reference labs basically understand genomics data and turn it into actionable reports for patients. So basically, cancer patients can get their blood or solid tumor sampled, and then our software helps analyze that information and then match the reports to clinical trials that are active, FDA approvals, guidelines for patients. And so we've been doing that since 2012. And as of maybe 7 or 8 years ago, we've been doing NLP, natural language processing, how to help our clients structure their unstructured data, take data out of PDFs or unstructured text and turn it into structured data. And then since 2022, when ChatGPT came out, we've been spending a lot of time trying to figure out how to actually bring large language models into the rest of our capabilities. And now it's about agents and model context protocol and a bunch of other cool things.
Awesome. I'd love to hear a little bit about sort of what prompted you all to prioritize MCP. It's a new spec, and you all are definitely on the cutting edge there. Would love to hear a little bit about sort of how you got there.
Sure. Yeah. So obviously, when large language models came out, I immediately, since our company is really about code and about knowledge, I wanted to know, well, what do these things actually do, and do they replace what we do? Do they augment what we do? And so right off the bat, it became clear to me that it was actually a very complementary technology. It helps with understanding the intent of users. It's understanding unstructured data, unstructured text. I was looking at things like RAG and other solutions like that, retrieval augmented generation, which is the idea of you ask a question, take that question, and then query a database and bring stuff back. And really in our domain, while that's useful in some aspects, it's not exactly what's needed. And what we really needed was something like an interactive kind of combination of large language models and what we have, which is a knowledge base or a knowledge graph. And so from the earliest days when ChatGPT had plugins in April of 2023, I actually built a ChatGPT plugin. And it didn't work. And the reason why it didn't work is just the models weren't smart enough yet. Even ChatGPT 4, which was a big leap over the original ChatGPT, it just wasn't smart enough. And then I also did what was called custom GPTs, which came out, I think, November or December later that year. And that didn't work either. I mean, it was okay. It just couldn't do like real problems. It could do kind of basic surfacey problems. And then when Model Context Protocol came out in November of 2024, I was a little bit hesitant to jump in, even though I was starting to get traction with my coding tools with Sonnet 3.5 and the reasoning models 01 and then 03. I could see how things were getting better because I felt like large language models had plateaued, at least for my use cases. And then when Model Context Protocol really kind of kicked in with people hyping it up a little bit on Twitter, I said, okay, let me go take a look at it again. And so that's what made me, start thinking about it, like, how could I use this in our work? And right now we're in a very heavily regulated space, right? We're in healthcare. We can't be making up recommendations. But what did jump out at me was an opportunity to say, well, what about these open source, open access APIs that are available for like things like clinical trials, publications through a service called PubMed, and then there's a variety of like kind of genomic information that's available. What if I just made it easier for people to get at that information and start talking to it through a chatbot, right? And could Model Context Protocol be that way of doing that? And when Claude Desktop and the Claude chatbot enabled MCP, I was like, this is it. This is how we're going to do it. And basically created the first 3 or so interfaces, and it just works great, right? You can start asking it questions. You can take your question, turn those into queries, and then bring that information right back to the LLM to then chat with. So, and really, it's been exciting. We've been adding a ton of new API endpoints to it, and we're going to keep adding API endpoints to it, and it's got a lot of positive feedback from folks.
Awesome. Sounds like you've definitely been there, sort of like every step of the way is how to connect external data sources to LLMs has kind of been evolving. I also
Yep.
suffered through custom GPTs for a while before MCP came out. I'd love to hear a little bit about what you think MCP is getting right that maybe previous iterations or something like basic API can't quite solve for.
Sure. Yeah. Well, so I think for one thing, an LLM can't really digest a full REST API. So that's a major problem, right? So REST was designed to be this very flexible, resource-based thing where you could use the full HTTP methodology, right, of like puts and patch and all this other stuff to try to do things at a resource level. It's just too overwhelming to a large language model. What they really want is a tool. They actually want RPC, right, the old school way of doing API integration. And so if you give them a tool and you just say, here is some ways of like twiddling how you want to call that tool, that's great. It can kind of learn how to use it with like the API docs or what have you. So I just think simplifying the tools is really key. And so model context protocol, really, honestly, it's a matter of timing, in my opinion, right? There's a lot of problems with the protocol itself. It's not a perfect protocol, but they did a great, I'm not trying to besmirch the team that did it. I think everyone recognizes that it's got a lot of rough edges to it. But for the most part, it works great. The LLMs can read the spec, understand the spec. They can now it's kind of like an agreed upon standard. And even if it's not perfect, we can iterate on it. And if everybody supports it, that just gives it a lot more, emphasis, a lot more support from the whole community. Just means that everybody will start using it and it kind of just wins. So in that way, that's why I'm a big fan of MCP, is mostly just because it's already kind of won at that space of like defining tools. So great, let's support the standard and let's go. But if you're in like the coding space, one of the kind of counter arguments, right, is that there's CLIs, command line interfaces, and tools like Claude Code and Codex and Gemini CLI and now AMP and OpenCode. There's like 20 of these things. And they all can talk to CLIs, command line interfaces, really well. And the benefit of that is they actually have, all of the history of Unix in their training weights. So they don't really need to teach them new tools. They actually have all these existing tools. So there's kind of this weird tension in the Twitterverse right now on MCP versus CLIs. But I think both have their spot. And I think that MCP is really good for net new things. Like if you're trying to define something like BioMCP, which did not exist 6 months ago, you really do have to have some sort of standard by which you can, describe your endpoints, describe the way you talk to it, and what the LLM can expect back, so that it actually knows what it's dealing with, versus some Unix command line that's been around for 50 years.
Yeah, definitely. And I think where you're using these, right? Is it a web-based chat interface, right? Is it in your IDE? Can also make a big difference, I think, in terms of like what the right tool for the job is. Tell us a little bit about sort of who's using BioMCP, where are they using it, how are they using it?
Yeah, so I have a few researchers that are using it. So they're basically, giving me active feedback of like how it does a good job for them. And these are domain experts, right? They're not software developers. So they're looking at it as like, I'm turning this on, and now this is basically doing 6 hours of Google searching in a half an hour, right? That's kind of the trade. It's not doing my work for me. It's just speeding me up and letting me ask questions where I can go do deep research, or I could kind of do, specific tasks. The other thing that I'm seeing a lot of is like, people want to do agents, right? They want to build agents. They don't really know what an agent is yet. A lot of folks don't. And I can give you my definition later if you want. But they want to build agents. They don't know what that means yet. But what BioMCP is, you can build a biomedical agent very quickly, right? There's a bunch of libraries that know how to talk to MCP. So you can basically give it BioMCP and say, here, go build me an agent that does something with clinical trials or does something with PubMed articles. And folks are kind of just experimenting and learning kind of the art of the possible, because by doing that, they can kind of, understand what really works, what doesn't work, where the LLMs fall down. And then once they actually figure out something that actually would be valuable and make an impact, then you can kind of redesign your system. You can say, okay, we don't need to use BioMCP, because BioMCP, I'm just putting it right out there, it's mostly a prototype engine, right? You're using it to like learn and explore. And then once you actually know what you want to build, then you should really build a targeted MCP or build it right into your application that you're integrating an LLM with, and then you can do that one specific thing really well, and make your agent do that one thing really well. So that's kind of how I'm seeing the split between domain experts and software developers for the most part.
Yeah, definitely. Tell us a little bit about how you went about building this MCP server. Yeah.
Yeah, so this was back in the olden days, right? So the olden days was in January and February of this year, 2025. And so I was doing a lot of grabbing the whole, clinicaltrials.gov API, which is a ginormous article, web document, grabbing that, putting that in Gemini, because Gemini has the 1 million context window, and basically asking it to understand it for me and turn it into a simplified version. Right, and I'm doing that with O1 and O3 and ChatGPT, and I'm doing all that kind of stuff. So it's really about how do I learn and digest these APIs as quickly as possible, and then turning those into basically a proxy server. And so what a proxy server means is you call BioMCP, and then BioMCP calls the backend system and brings back the relevant info. And so I did that for 3 or 4 initial endpoints, and we've now added about 35 of them. And the work is pretty vanilla Python, to be honest, right? You're basically describing an API endpoint using a system similar to Fast API or REST API's service. You describe it using a software called Pydantic, which is a great way of describing a complicated nested object. And that alone, by describing the different fields that is expected as part of the query, the input, and putting descriptions in there and saying if it's an integer or a float or a string, that information alone is enough for the LLM to understand what the inputs and outputs are for the MCP, and then it knows how to call it, right? So if you ask it questions about, well, what are the open clinical trials for this drug, for this biomarker in this, in this city, it knows exactly how to grab out those concepts, even if you didn't spell it out exactly right, put it in the structured query, send it to the back end, get the response, and then understand what to do next. And so that's all built on a technology called Fast MCP, which is part of the, kind of the Model Context Protocol standard SDK. And, all the software for BioMCP, if you go to biomcp.org, it's all there. We got tons of documentation, and you can go into the code and you can actually see how the proxying actually works to these different backends.
What would you say was the hardest part of building this MCP server?
Yeah, I would have said it was going to be how do I integrate with the authentication, right? So I didn't actually end up doing that part. My VP of technology colleague Justin did that part, but basically we stood up a remote version, right? So we wanted to make it so that not only developers could use this thing where they had to because you have to know how to install UV and UVX and all these other Python things to make it run on your server or run on your local computer. Well, we wanted just to have a remote endpoint that someone could basically press a button, type in a URL, click 1 or 2 more buttons, maybe to agree to their Google account being used to authenticate, and then be off to the races using our remote proxy. And the value, of course, for that is, someone just doesn't have to go through that process of setting it up. But the reason why we wanted to authenticate, honestly, is we just didn't want spam bots hitting all these backend servers, right? I didn't want to be the reason why the clinical trials website went down because somebody found our API endpoint. So basically, we stood that up using Cloudflare. So Cloudflare has a simple system for hooking up MCP, and then we had a direct integration with Stytch. And honestly, it took less than a day, right? And probably less than half a day to actually hook it all up. And now, when you go in, you can type in the remote URL that we provide folks in our documentation. You click 2 or 3 buttons, and you have authenticated with Google. And now, when you're going to our remote server, it's going through the authentication layer through Stytch, through Cloudflare, and then the calls are then happening to the backend servers, and the results are coming back. Piece of cake. So really, nothing was. I wouldn't say anything super hard right now, and that's kind of the goal, the dreamland of this current world of agentic coding, right? Is that software development, like the syntax and the problem solving and the debugging, those problems, not that they disappear totally, it just goes from being oh no, I ran into this really hard problem and it's going to take me a week to solve it, to I found this really hard problem and it took my agent 20 minutes to solve it while I was doing something else, right? It's just a lot, better, a lot better world. And the folks here at Stytch, this was a great technology, plugs in perfectly for MCPs. So if you're building something that's kind of a cloud-based thing, I would certainly recommend Stytch.
Amazing. Perfect pitch for Stytch.
Yeah, there you go.
It sounds like you used a lot of, out of the box SDKs, et cetera, to build this. I think that is a great way to approach building MCP servers, because you don't want to, necessarily have to be staying up to date with all of the little updates that are happening to the spec, et cetera, right? I'd recommend that as a best practice to folks. I'm curious if there's other things that you'd recommend that you learned along this journey, if people are starting to think about building MCP servers.
Yeah, I mean, what's the goal? What is the goal, right? So the goal to me is either building assistants or agents. They're kind of the same thing. It just depends on your perspective of how they're running. Are they in the background? Are they running a workflow? Are you talking through a chatbot? Regardless, they're using these tools. So then the goal is like, how do you figure out what do you want these things to be able to do for you on your behalf, or what workflow do you want them to run? And then at that point, what you need to figure out is, how do I design my tool set so that they're kind of, on rails, so that the agent doesn't get confused on what to do, the assistant doesn't get confused what to do. And that's really the point of MCP. The point of MCP is really to put guardrails around what calls need to happen, so the agent knows exactly what next steps to do, knows how to interpret the answers, and then can pivot and do another thing. So what you're doing is you're basically giving these things kind of like a program to follow, right? A metacognitive program is kind of one term I've heard, which is you're going from step to step to step. And then at each step, you're doing a little bit of judgment, right? You're making some decisions based on the context of what has happened before and what you're looking at right now and what's ahead of you. So you have to kind of take on this mindset of how the LLM, quote unquote, thinks about it. Apologize for the anthropomorphizing of it. But you have to think about like how it processes the information, I guess is a better word. How does it process that information to make those quote unquote next decisions, which is not really decisions, it's generating of JSON to make a call to a tool. And that's all that's happening, right? There's nothing magical about this stuff. So if you can understand how the mechanics work, it'll allow you to define and design these interfaces that you're building, so that the agents don't struggle, right? You're trying to make it as simple as possible for these agents to know what the next best thing to do is. And if you take that approach to it, you'll just have a much better job of like designing these MCPs.
Yeah, I think that's really good advice. I think something I see people struggle with sometimes is just like exposing their API endpoints as an MCP server, right? And like the way that the LLMs are going to interact with that MCP server is very different than like the developer that's using your API endpoints. And I think that perspective of like, okay, how is this LLM actually going to interact with it? What are they going to be trying to do? And how do I package then what I need to in a way that is really easy for them to understand? I think that's a key that folks are sometimes missing when thinking about like, what is MCP? Why is it different than APIs, right? Why do I need to do this thing? There's a lot of power to be had in that framing.
Right. The main constraint at this point is the context window, right? So if you don't understand that concept, you have to go learn about context windows and context engineering and all these terms that folks are using. And all that just means is there's, depending on the model, let's just say 200,000 tokens or words, right? So like 150,000 words. That's all this thing can understand or keep in its memory at once. So and whatever you use to describe your tools, that counts against your window here. And the more times that it fails to call the right thing, it's going to be filling up its window with junk just to learn what the right thing to do is. And then once it finally figures out the right thing to do, then you're left with that amount of tokens left to actually do what you wanted to do and to actually get the job done.
Yeah, definitely. What's something that you want to see evolve either in the tooling around building MCP servers or in the MCP spec itself over the next couple months?
I'm kind of interested in that sampling thing, right? Which is the idea that the MCP server can ask the LLM to do some of the not deterministic, the probabilistic stuff, like the actual LLM stuff. The MCP can actually ask the client to kind of do some stuff for it. That's an interesting thing. I haven't seen it. I've seen a couple demos of it. Haven't seen many folks actually take advantage of it. The idea of behind prompts are the resources that MCP has. So we actually have 2 prompts baked into BioMCP. The first one is just kind of like a generic, here's all the tools. And you really want to load that up because, like I said before, Claude and ChatGPT, they don't know about BioMCP and what it can actually do. So by loading up that original prompt or our initial prompt that we give you, it just teaches it about all the tools. And it's just better than what even the MCP does. It is using up some tokens though. And then the other one I have is actually a prompt for doing a deep research kind of persona. And it uses another technique called sequential thinking, which basically forces the LLM to do multiple steps. So it's kind of doing that workflow thing. And I'm actually spending a lot of my time right now on that particular problem, which is how do I have agents? I don't necessarily need an agent that can just do any task, whatever. I don't think that they're good enough at that yet. So I'm actually building workflows. So I'm building multi-step workflows with some basic logic, right? If then else and things like that for agents. And the agents at every step are able to then use whatever tools they need to get that particular subtask done before they move on to the next subtask. So MCPs are just one tool in my toolbox, right? Like command line interfaces, they're great at calling those as well. So I'm really not too hung up on whether it has to be MCP versus command line interfaces. Obviously, the MCP is a great technique if you're dealing with remote capabilities. If you're trying to talk to a service that's hosted by a third party or centralized in some way.
Yeah, I think it's really cool to see like the ChatGPT kind of like App Store concept come to life. Like that's a great way to discover MCP servers. I could see there being something too for kind of like the prompts that go along with those MCP servers, but also just generally, like I think there's so much more sort of knowledge sharing and just like discoverability that could be solved in the future. So hopefully the clients are working on something like that.
Yeah, I will be hesitant. I have to say something at least. These MCP servers, you have to know who's behind them. So there's a chance for what's called prompt injection, right? So do not just start using MCPs from random organizations, random people, random things you find on GitHub. You should trust it and validate it. That's why we open source this software, right? You can go look at all the software that we have and validate it for yourself if you're interested. Or have Claude do it for you. Download the code base and have Claude dig through it. But yeah, there are people that are now just finding hacks for like making your local agent, like be able to send tokens to a third-party website. So be aware that these hacks are starting to happen right now. And with Model Context Protocol, I do think that it is an attack vector that people should be at least aware of, and make sure you're not providing Claude or whoever is accessing your MCPs, make sure that they don't have access to anything that you are nervous about them, sharing, whether it's like API tokens or what have you.
Yeah, I think figuring out security for MCP servers, especially when it comes to that kind of like understanding the supply chain of like who's building this, who has access to maybe modify the code, et cetera, definitely going to be something that needs to be solved for wider adoption. What are some of the things that you sort of have on the roadmap up next for BioMCP?
Yeah, we got another 5 or 10 kind of API endpoints that I'm going to try to get baked into there, which is mostly around like molecular variants. So what are these genomic variants that are happening, and what do they mean, right? So there's a lot of open databases that we can tap into for BioMCP. So we've got a few of those listed, and more precision oncology, precision medicine type use cases around big data around patients and patient populations and how prevalent are certain mutations in certain disease types. Like a lot of that data lives out there. By having it all behind a single BioMCP, API, it'll just make it easier for folks that are trying to do, basic research and be able to kind of retrieve all this information kind of at the point of question, right? Like at the point of the time that they're asking the question, or if they've given their agent a goal, and the agent can kind of use all the different tools it has access to bring together and synthesize all that information. I think it's really powerful. And then as a company, we're really focused on now the on-prem version of this, right? So we have, very similar versions to these open source APIs, but we actually have private versions that are a little bit more powerful because they have like a semantic layer on top of them that allows for, just more connectivity beyond just what BioMCP supports is more a keyword-based solution. So, and we're doing that behind the firewall so that they can actually be HIPAA compliant, and make sure we don't lose anyone's PHI. The way we've designed BioMCP, just to be clear, there's no slots for PHI, right? There's no spots for a patient's name or their medical record number or any other identifying information. So it shouldn't leak through, but organizations are very keen to make sure no data leaves their four walls, which makes sense. So that's why we're building an on-prem version that's also a little bit more powerful for specific use cases that we have in mind, right? For helping our clients either do, reporting, data extraction, structuring, and then clinical trials is a a big challenge for our industry. Only 5 or 6% of cancer patients get on clinical trials, and a lot of that is just honestly the level of effort of digesting the information and screening, and then kind of this matchmaking work of just-in-time matchmaking of patients to an open trial slot is actually just really hard to do. And our software and our agents now are helping folks do that.
Very cool. Excited to see BioMCP continue to evolve. And Thank you so much for joining us today. It was great having you on the show.
Yep. Thank you for your time.